Almost everything can be animated in SwiftUI, although some things take a little encouragement, shall we say. Let's start with the easy stuff. We can trigger an explicit animation using with animation. For example, if I had some state in here to store a scale value of 1.0 by default, then hello world, and now I'll do a scale effect applying that scale here. And when I tap this thing, I'll do with animation scale plus equals 1 like that. And of course, we can tap on it and it'll get bigger and bigger and bigger. That makes sense. We can also use implicit animation. So rather than having the with animation call here, we could have said, just take that out. And instead, apply the implicit animation here of default, making sure to bind that to the scale value. Remember, do not use these implicit animations without providing the value parameter because that's been deprecated since iOS 15 and later. And so the reason is it would animate every single change, even things like device rotation, which is confusing. That works too, so we can click our way upwards and it's fine. Boom, there we go. Great. But not everything works this way, okay? For example, if we had several overlapping views, we might want to animate the z-index of one of these views. For example, if I had said, let's say private var red at front is false, and our colors will be an array of color equal to, let's do blue, green, and then orange, purple, 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 and mint, like that. I'll then draw a bunch of rounded rects overlapping with a button to change it. So I'll say the VStack here with a button saying toggle z-index, and then with animation, linear, duration of 1 second, red at front toggle. So when it's pressed, move the red thing to the front or not. Below the button, I'll place a Z stack with a rounded rectangle of a corner radius of 25, like that, and then fill that thing with red. And for its z-index, I'll say if red's at front is true, use 6, otherwise use 0. Then after that, I'll draw 5 other rounded rects with different z-indexes below that. So I'll say we have a for each loop here. Let's scroll down just a little bit. For each 0 to 5 with I coming in, do a rounded rectangle, same corner radius, filled in with that color from our array. I'll offset it downwards each time. So we'll say X will be double of I plus 1 times 20, and Y of double I plus 1 times 20. And then a z-index of double I. Boom. So it'll go in different positions along the lines. Hopefully, I in even, there we go. And finally, I'll give this thing a fixed size, so it doesn't take up the whole screen. So I'll say it's a frame, width 200, height 200. And the code is correct. Okay, I'm running it back here. It looks great. That's my overlapping stuff here. And this button should toggle the z-index of our red rectangle from the back to the front. When I press on it, you're going to see it jumps to the front immediately rather than animating through the values 0 to 6, right? So it's not great. It's not animatable currently because by default, z-index is not animatable with SwiftUI, or at least not where I say not by default. We can make our z-index code animate with a surprisingly small change, and the technique involved can be applied in numerous other places. In fact, you can animate practically anything you want to if you really try hard enough. The key is to create a new view modifier that conforms to the animatable protocol, which has the job of handling whatever you want to animate in your animation. So we might say there's a new view modifier up here. I will call it, struct first, an animatable z-index modifier. View modifier and animatable. The index we're showing, the z-index we happen to have, is a double. And then our body method here will just do our content with a z-index of our index. Now, the name here is quite specific. It's an animatable z-index modifier, not an animated z modifier. We're applying, also providing the ability for this thing to animate if the call site chooses. Whether or not it actually is animated depends on how it's used, right? So it's not always animated, it's animatable. Now, while it's possible to add that modifier directly to our views, we can also, and if you get a better idea to do so, wrap them in a view extension to make our code easier to read. So we'll say func animatable z-index, index is a double, some view. And now self.modifier animatable z-index, there it is, with that index like that. And so now, rather than saying I want to apply a specific z-index here, oops, Tracy, it's unhappy with me, I've made a mistake somewhere, I'm sorry, I'm calling myself somehow, that's a bad idea. Let's try that again, animatable, there we go, that's the, no, humbug, am I just doing something wrong here? Animatable z-index modifier, I'm sorry, I'm being silly, sorry folks. Index, try again, there we go, okay. We can now use that down in our z-index down here. We can say our red thing is an animatable z-index. And that still won't work, right? We've now got this z-index in jump to and from, but it's still not actually animating despite me trying to animate it. What's happening here is that the animatable protocol, what it really does is give us the ability to read and write some kind of interpolated value over time. And as we are animating our numbers between 6 and 0 or 0 and 6, the animatable protocol gives us values like 0.1, 1.35, 4.825, and so on, as those values change, depending on the curve we've chosen. And that's what it does. It just sends the value, here you go, here's a new one again and again and again. It's down to us to decide what we do with it. In this case, the interpolated values it sends us are exactly what we want for the z-index for our rounded rectangle, and so our view will move smoothly from 6 to 0 or 0 to 6. And so when this animatable protocol attempts to provide some information to us, some animation data to us, we shall assign that to our index property. So we'll say our animatable data is a double. And we get that value, just send back index, and we set that value, store an index. And this thing here comes from animatable. That's what it's sending in. And if you don't provide one, it'll do an empty one by default, it won't do anything at all. If you do provide one, now it's sending in real values and we're using them straight away. So I'll press Command R to build and run our code, and now we'll see the red rectangle move smoothly back and forward between the other ones, like that. Now, if you want to, you can actually make this code even simpler. You can simply just call your property animatable data, like this, is a double, like that, and use it directly, right? Do that here and then again here, and you'll get exactly the same result. All it cares about as a protocol is that you are overriding that animatable data value and doing something with it. That's what we care about. Now, I'm going to actually go back a little bit. I prefer not to do that personally. It's a bit of a clumsy way of working, but you can do it. Now, if you're curious what's happening here, I recommend you add a print statement into the setter we just made. So you can see exactly what the animatable protocol is doing behind the scenes. So you might say print that new value and then semicolon indexes new value like that. And with that in place, now you will see all the intermediate values being printed out down here. Boom. These are the intermediate values being sent. So ZX will be 0, 0, 0, then 0.0999, then 0.2, 0.3, so you can see that's what we're making our Z-index to along the way. And it's honestly, it's another feature of Swift UI that looks like magic, but is actually surprisingly simple internally. Now, having this kind of control is particularly important if you need to support iOS versions below iOS 16, because a number of things couldn't be animated before iOS 16, so 15.6 and below. For example, the system font. You want to animate from A size to B size, works out of the box in iOS 16 and later. If you want backwards compatibility, relying on animatable becomes important. You might have made a modifier like this. There's a struct animatable, again, font modifier, a view modifier that's animatable with a double size, and the animatable data this time again will be a double, with the getter being return size and the setter assigning size from the new value. And then for the body, outside the property even, after the body here, you'd say my content.font, system font size of, size like that. And again, make an extension to view so it's easier to use. So extension view, func animatable font size double, return some view, self.modifier, Let's get it right this time. Animatable font. There it is. Champ. Of that size. And now go ahead and start using it so you can, make your text adjust freely before iOS 16. So something like this would do it. Scale up equals false. And you'd say, get rid of all this code here. Text, hello world. Dot animatable font. Size of, if scale up is true, 56, otherwise 24. Then on tap gesture, we'll do with animation dot spring, response 0.5, damping fraction 0.5, scale up dot toggle. Boom. And that should more or less work. Boom. Really nice. Now, again, that kind of thing does work much, much better with iOS 16 or later. If you want to, you can just change across to a regular font modifier. If you're only doing that one version, you might say a font of system. Size would then be the same code like that, using that for your font. And hopefully now that in place is the iOS 16 equivalent. It will also scale up and down. But again, that's not working iOS 15.x, 14, 13, not available then. What I would say, if you're using our custom version, I don't know how Apple are doing it, but our custom version here, making the font animate from small to big and overshoot and then bounce down again. You're making lots and lots of font sizes being created here. It's a great effect, but it's very easily overused in terms of performance. So be careful doing that. I obviously hope Apple's own solution from iOS 16 onwards is somehow more optimized.